Good morning and greetings to lecturers, evaluator and fellow friends. Today our group K10 will present the design project with title of Production of Lactic Acid from Rice Straw by Fermentation. Allow me to introduce our group member. Me, myself is AFNAN. Along with me is RAMPRASAD Rao.
Yes.
And also we have PENG.
Yes.
And of course we have ARMIDHA.
Yes.
Okay, moving on to introduction. So our main raw material is the rice straw. We have the most composition of cellulose, about 34%. So also we decide and compare the raw materials based from the three most waste generated from agriculture in Malaysia, which is the corn stover, rice straw, and also pineapple waste. And we decide to choose the rice straw as our main raw material according to the factor rating. And also we can see here the application in pharmaceutical, food industry, and also cosmetics. It also has an advantage as a sanitizer product, which a high purity active ingredient. It also have an antiviral properties, and also it's very effective against gram-negative bacteria. Moving on.
Okay, now we go to the economy aspect. So there's a graph for supply and demand of lactic acid. The estimated plant capacity. The plant will be operating at 340 days a year for 24 hours. And we decided to cover 4% from the global division, which is the plant capacity of lactic acid is 15,282 kilogram per hour. Next.
Next is for the process design level 1 and level 2. The input-output structures for our production of lactic acid is shown, and the process involved are the alkaline treatment, acid hydrolysis, fermentations, and the purification process. So for the reaction 1, which is the conversion of glucose from cellulose, operating temperature is 140 degrees Celsius and pressure 1.5 bar. The catalyst is sulfonate coated mesophorous carbon, and the packed reactor is used with the conversion of 0.8. Reaction 2 is the fermentations of lactic acid from glucose, and the operating condition is temperature 35 degrees Celsius and pressure 1.5 bar with the microbe lactobacillus species, and the batch reactor is used with the conversion of 0.8.
So we go to the summary, process design level 3, which is involved the reactor 1 and also fermenter. Next is the conceptual design summary for process design level 4, which is we have two separation process that involve filtration, evaporation, centrifugation, filtration, and purification by distillation column to produce lactic acid. We already done the manual and software calculation by using SuperPro. Okay, now we go to the summary of conceptual design, reactor and separator. The table shows the type, the selection, the dimension, and also the operating cost. Next.
The economic potential analysis is done. So the cost of raw material include in level 2, the cost of reactor is level 3, and the cost of separator in level 4. The best conversion used is 0.8. And as a conclusion, the potential economy for is 163 billion per year. As a conclusion, the economic potential shows a profitable production.
So these are the process flow diagram for our production, as we can see in the slide. So the next is the process flow diagram after the heat integration. So after we done the pitch analysis with cascade and so on. So we added an heater E101 as string 4 and outlet is string 5. So after the heat integration, the total percentage of energy integration we provide is 98.05%. So these are the PNID of the heat integration.
So for the instrumentation control summary, we have 7 equipment which we need to control. So the type of controller such as the level, pH, temperature, flows, and anti-foam controllers. And the controller has been identified the reasons to be used for each equipment. Next.
So these are the related acts and the regulation that we need to follow for our process. One of the act is EQA 1974. So that is EQA 1974 Schedule Waste Regulation 2005, and also EQA 1974 is the Industrial Effluent Regulation 2009. So every act, there is a regulation involved in our process. So the next is OSHA 1994. We need to follow this act because we produce carbon dioxide in our fermentation process. So according to OSHA 1994, the standard concentration of CO2 is 5000 ppm as an 8-hour time weight average concentration. And also CMA 96, which is under OSHA 1994. We need this to establish and maintain a good management system for controlling any major accidents. And also the next, the Factory and Machinery 1967, is to manage safety and health problems associated with the manufacturing industry and the tools. So for example, in our production, only the certified or experienced employers are allowed to operate high temperature of hydrolysis reactor to avoid any accident. Okay.
As for the hazard identification, we find about 5 chemicals that need to be identified, which is the sodium hydroxide, sulfur nitrate, catalyst, ammonium nitrate, lactic acid, and also the carbon dioxide. We also perform the hazard analysis and also identified the hazardous properties such as toxicity, flammability, corrosiveness, and also the permissible limit of the hazardous material. Next. As for the hazard system, we also try to evaluate and the transmission paths, receptor, barrier physically and non-physical. Okay, next. And also as for the hierarchy, we perform the evaluation for the identification, risk assessment, and also risk control. From the work activity, we can find that one involve a very high risk assessment, which is the during reaction in reactor, which could lead to explosion. So a control is need to perform, such as place a experienced worker, and also planning emergency response plan, and also could be installing the high temperature alarm. As for the other activity, we can consider it as a medium risk. Moving on.
So for other plant location, we choose 4 places, which is Tanjung Maling, Bakar Arang, Klang, and Penang. From our factor rating, we found that Bakar is the best location for our plant. So these are the site location of our plant. So for the factory rating, we include the selection parameter such as type of industrial preferred, area of land, price of land, water supply, power supply, raw material supply, labor availability, port facility, airport, and also the railway facilities to do the factory rating. So from the rating, we found the Bakar area is the best place for our site.
To go to the plant layout, so there are several important things that we consider. First is the easily and safely access of emergency services. Second, the direction of prevailing wind. And then we have the assembly area, provide emergency exit and assembly point. Next is the separate section for plant process. And lastly, the control access of unit.
As for the waste management, there are 3 types of waste that we need to consider, which is the gas for the carbon dioxide, and also the solid for biomass, and also the liquid for wastewater. So next, there are parameters that we need to consider to follow the standard B for our wastewater treatment plant, which is the temperature, pH, BOD, COD value, and also suspended solid. As for the waste minimization, the sodium hydroxide can be used back to minimize the wastage, and also the black liquor, we can change it to fuel by gasification, which could be a selling factor for our economy potential. Next.
So these are the PFD for our wastewater treatment plant. So we use 1 equalization tank, 1 coagulation tank, 3 clarifier tank, 2 aeration tank, 2 slush tank, and also lastly 2 filter press tank. So after the treatment of the wastewater, we can see at the string table at number 10. So the BOD, COD, and the suspended solid has followed the standard B as we follow for our plant.
So next is for the economic analysis. Our plant is designed to operate for 20 years, which is from year 2023 to year 2043. The operation rate on the first year is 50% and followed by 90% and 100% for the coming years. So as a conclusion, our total capital investment is 210 million per year, and the total production cost is 256.5 million per year, while the depreciation is 7 million per year.
So next is the summary of profitability analysis. The return of investment that we get is 0.54 per year, and the payback period that we get is 1.43 year. Next is the net present value, which is 108 million. Next is the RN value, which is almost 2 billion. And lastly is the discounted cash flow rate, which is 0.5819, and our project is acceptable and considerable. We go to the break-even analysis graph. Both graphs shows that our income is exceed the expenditure, and the production cost of our lactic acid is 20 ringgit 58 cents per kilogram. We decided to sell it at 40 ringgit per kilogram because of the price of competing company is at the range of 40 to 50 ringgit. So the profit margin is 20%, which is considered high and good profit margin.
As a conclusion, lactic acid is produced from our plant, which act as micro agents in hand sanitizer, rice straw as a feedstock, with a plant capacity is 124.7 kilotons per year, with Pakar Arang Sungai Petani Kedah, with the size of 10 acres. The rice material used is sodium hydroxide, CMK catalyst, and lactobacillus gases, sodium nitrate, and water. The process involves are pre-treatment, hydrolysis, fermentations, and purifications, with the conversion of glucose 80%, and the potential economy for is 163.2 million per year, which is profitable. 98% of energy has been recovered from utility access energies. Control system has been designed and to be installed to the plant. The legal requirement, chemical and physical hazards are identified. The waste management has been done, and the BOD and COD has been decreased after the waste management, and the project is profitable and considerable after economic analysis. So here comes to the end from the group K10. Thank you.